Hi, welcome to the Mathematics in my channel. Today we are going to solve another interesting integral. Integral from 0 to 1 x raised to the golden ratio minus 1 square over log square of x dx. Well, how to begin? Okay, first I am going to define a function f of p is equal to integral from 0 to 1 x to the p minus 1 square over log square of x dx. Well, then we can simplify this. 0 to 1 x to the 2 times p minus 2 times x to the p plus 1 over log square of x dx. Okay, this is the f of v. Now I am going to take the derivative. So f dash of v is equal to integral from 0 to 1. We know x to the 2p, here 1 is a constant, so this is equal to 0, and x to the 2p, 2x to the p, so we can write 2 here, or we will have 2 here, we will have 2, so we can write 2 times x to the 2p minus x to the p over log square of x times log of x dx. Now this log of x, log square x, get cancelled, and now we will have 2 times integral from 0 to 1 x to the 2p minus x to the p over log of x. Well, then I am going to take second derivative. So f double dash of p is equal to, now we know here 2 will come, so here 4, so 4 times integral from 0 to 1 x to the 2p dx, and here 2, so here minus 2 integral from 0 to 1 x to the p dx. Okay, now we can differentiate, so we can write this is equal to f double dash of p is equal to 4 times, now integration of x to the 2p, we know x to the 2p plus 1 over 2p plus 1 from 0 to 1 minus 2 x to the p plus 1 over p plus 1 from 0 to 1. Now if we plug in upper limit and lower limit, we will have 4 over 2p plus 1 minus 2 over p plus 1. Well, now we know if we take f dash of 0, f dash of 0 we know 0, therefore we can write f dash of p, f dash of p is equal to integral from 0 to p f double dash of q, f double dash of q. So we can write now this is equal to 0 to p 4 over 2 times q plus 1 minus 2 over q plus 1 here dq, here dq. Okay, now we can integrate, so here 4, so here 2. Now we know the derivative of 2q plus 1 is equal to 2, so here 2 replace in the numerator, so we can write 2 times natural log of 2 times q plus 1 minus 2 times natural log of q plus 1. and limit 0 to 1. Okay, if we plug in limits, we will have 2 times natural log of 2p plus 1 minus 2 times natural log of p plus 1. Well, then also we know f of 0 is equal to 0. Therefore, we know I is equal to f of pi golden ratio, and we can write this is equal to 0 to pi f dash of p. Okay, then we can write 0 to golden ratio. Here we know 2 times natural log of 2p plus 1 minus 2 times natural log of p plus 1 dp. Okay, then we can write now this is equal to now we have to integrate, so we can integrate. I skip this process and we will have 2p plus 1 natural log of 2p plus 1 minus 2 times p plus 1 natural log of p plus 1 limit 0 to golden ratio. Okay, now we can simplify this. 2 times pi plus 1 natural log of 2 times pi plus 1 minus 2 times pi plus 1 natural log of 5 plus 1. Okay, then we know this property phi golden ratio plus 1 is equal to square of golden ratio, and also 2 times golden ratio plus 1 is equal to golden ratio cube. So we can simplify this like 3 times 2 times pi plus 1 natural log of phi minus 4 times pi plus 1 natural log of pi, and this is equal to 2 times pi minus 1 natural log of pi. Now 2 pi we know 1 plus square root of 5 plus 2, here minus 1, here natural log of 5. Now these 2 get cancelled, 1 get cancelled, and we will have the square root of pi times natural log of golden ratio. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.